Hello everyone, welcome back to the channel. Today we are going to do something really exciting. We are going to add SD card storage to our STM32 project. Okay, so basically here you can see this interface. So with this you will able to save sensor data for days or week into the SD card. Okay, create configuration file, log events for any data that you want on SD card. Because in embedded system we have different type of memory available with us, but the SD card is only option where we can have 8 GB, 16 GB or 32 GB, 64 GB, right, with very low cost. But ultimately you have to have this type of interface, and then you can use any size of SD card. Okay, so we can, after this demo you will able to do all this. So here the best part, that we will use very limited connections. Okay, because SD card module is having SPI interface. So I will show you that in the diagram also. So here, with using only 4 to 5 wires, we can develop this. And then once you have this setup, with any project you can interface this, and you can have this onboard storage with you, right? So this open up so many possibilities for you in future, right? Uh, Everything is available on GitHub link, right? I have provided this. You can see on this link. I will also add this in description of the video. I provided everything in core project, this header file, this C files, right? Whatever required for this video or for this demo, I have provided this in this GitHub link. Okay. So now to understand the basic aim of today's video. Okay. So now, first of all, we will start creating new project. Okay, then I will show you the wire connections as well. So basically, for the new project, let us open this. Here, select our board. Sorry, yes, board selection, and here you have to select the board. 1 minute. I think I have to search in this part number if I'm not wrong. Yes, this is. And again here STM32, and you know that we have 7Z part number 7Z 767ZI. I have to select this one. Now I'm giving the name SD demo English. Okay, and now you have to start creating this. So now during pin configuration, I will show you exactly which pins to connect where. Okay, and okay, so here you can see the SD card module, okay, which I've used in the project. So basically, this card is having slot where you have to insert your SD card, and then these pins. So you can see in pins we have MOSI, MISO, clock, and chip select. So these 4 pins we're going to use from SPI interface, and then power supply and ground. So here I have provided 3.3 volt, and ground is connected with the ground. Okay, so let us start this. So initially I will clear all the pins. Right, let us start with the crystal. So first of all we have to provide the clock. This is required for each and every project. Right. Now next is, let us connect the SPI1. Okay. Here you can see PA5, PA6, PA7. These three pins are now enabled. So in SPI, I will just set a few things. First of all, 8-bit, okay, and then this prescaler, let us set it to 256. That's it, okay. And now I have to enable this PD10, if I'm not wrong, for the chip select. Okay, so this is also required. PD14, not PD10. I'm sorry. Just check the connections in my list, and PD14 will be the chip select. So for chip select, we can configure is at a GPIO output. And now let us enable UART3. This is our internal UART where we can display the messages, and you have to select asynchronous. Keep baud rate same as it is. Now simply generate the code. Now this will generate the code. Okay. Meanwhile, let us use this our hardware, our program, and let us start adding few files. So first of all, you have to add this sd underscore spi.h file. Okay. So let me just show you how to add this file. So to select the core, then inc, here you have to provide the name of the file. Just copy the content, paste it. That's it. Okay. Now next is sd underscore spi.c. So let us select this in inc, select new, select file name, finish, copy the code. That's it. Okay. And one more thing we have to do, that we have to have this FATF, right? It's basically third party library, user defined function. We will going to write this, and we will talk with SD card using this module as FATF. So that part I think I have just forgot to configure. So again, you have to open this, okay, and here you have to go with middleware FATF, okay. Here you have to select user define. That's it, right? And all other things we will set later on. Again, it will generate the code. It will add FATF files over here. You can see some default files are there, right? Now our previous added files are as it is, so that part is already we have covered. Now here in FATF, we have to modify this function, right? So simply in FATF, you have to select the target, open user disk IO function, okay, and just copy this as it is, right? That's it. So okay, I have just covered all the required configuration part, and now let us write the main code. So in main code also some base code is already generated, and we will take our main code from here only. And I will just explain you what this main code will do. Okay, here you can see we have UART SPI handler, right? We have just added one function. Whenever I will simply write printf function, it will going to use UART transmit, right? UART transmit. So then in C language we have printf message. Here also in code, if I will use printf, it will display the message on UART. That's it. Okay. So this is redirect printf to UART. Okay. Now here is the our main function sd simple test. So what we are doing, we are simply printing few messages, right? This is the function if sd mount not equal to 0. So sd mount function is written, right? And we are just checking if it is not equal to 0. Means if it is equal to 0, it means that it cannot mount the SD card, or it could be SD card not present, whatever, right? Multiple things could be possible. But if SD card is present, so this will become false, right? So as the SD mount return will not equal to 0, and it will execute this part. SD card, sorry, if it is not equal to 0, it is fail, and it will execute this part. So SD card test fail, troubleshooting, check SD card, verify wiring. You have to verify multiple things, right? If this is equal to 0, if SD mount will return 0, okay, my mistake in previously I just told reverse thing, but if SD card is equal to 0, it means our card is successfully mounted. So it will go for the next step. Now here writing test file, where we are just generating one hello.txt file. Hello from this device, we are just writing these three messages. Now instead of 25, I will just change this date from 25 to 26 because today is 26, right? And then uh, it will write this file. So to write the file, CM, you have to simply write SD write file, file name, test data. You can see test data means what content we want to write. And if this is equal to 0, if this function will return 0, it means it performed this operation successfully. If this is not equal to 0, so again we have the message writing fail, right? So by observing UART, we can have the idea that what is happening, how the flow is going, right? So this is what the function is. Then reading the file, it will read the file, right? This is just a check. Means after writing, we are also reading the file. We are just SD card read. We will read all the file written in SD card, right? We will display successfully read file. Whatever files are present, it will display on the UART. So if I will run this first time, it will write the file and then it will reply back that okay, this file is already written. Okay, I will do multiple tests to show you how it can write different files, right? And it also after this it will append more data appending to this file, append line 1, append line 2. So after successfully getting confirmation that okay, this file is created, we will write more data on at that file hello.txt. Okay, and then it will display message successfully appended data. That's it. And in from main function we are simply calling this. So here you can see up to here we are just configuring. So STM32 cube IDE automatically generate this part up to here, and then we are just simply printing some message over the UART, and we are calling SD simple text function. Okay, and as I explained you earlier, this SD simple text function will simply mount the SD card, write the hello.txt file in it, show you which files are present in SD card, and append the data. That's it. Okay, it's very simple. You can see. And now I'm just copying this whole code as it is over this main file. Okay, and let us debug this. And now I will show you the hardware setup as well. So here is the hardware. You can see this is the SD card module. This is our Nucleo 144 board. Okay, I will also show you the pin diagram. So here you can see the pin diagram is there. So this part here you can see these pins are actually these pins, right? You can see PA5, PA6, PA7. The SD card is connected with this pin PA5, PA6, PA7. Okay, and here it's a supply, power supply, and ground. So you can see uh, three wire for SPI, one for chip select. They are connected with this, and these are power supply and ground. You can see SD card is inserted. This is how you can remove the SD card. This is how you can insert the SD card. And I have card reader as well. So after performing this experiment, I will insert this card into this card reader and show you the file on the PC. So this is what the overall setup is, right? So now let us load our code on the module. So this is You can see successfully code build. Now I'm just releasing the target, set few things before loading the code. Post build, hex file, okay, and then release this again. And now here you will see hex file. It will generate the hex file which you can use later on anywhere. Right now I'm just loading the code from here only, right? So let us just write sd demo our project, right? And here you have to select the release part. Now let let us open real term as well, because we are going to display message. This controller is going to display message on UR3. Okay, now let us load this. You can also check this hardware. You can see this LED blinking, and let us open this. Now let me just reset this microcontroller. 1 minute, what happened? Okay, an issue is there, right? I just missed that part. So let us just copy this main.c file, and I will tell you what we just missed. So if you remember that our onboard UART in RPA9 and PA10, so you have to change this because default pins are different, but we have to change this from PA8 and PA9 if you remember our previous videos. Okay, let us just regenerate the code. I have copied that, so it will not change anything. I'm just simply copy same main code. Okay, now release the target. Again, I am uploading the code. Check this. Here you can see the message, right? Starting from this STM Nucleo 144 board interface SPI CS pin PD14, right? Mounting SD card initial mount successfully. It here you can see write file. Hello from this message. SD card is working. Date is 25. Okay, so I just forgot to change it, but that is okay. Then files on SD card. So we have this one system file on hello.txt, which we have just uh, wrote on the SD card. SD card unmount and test successfully completed. Now let me change something. Okay, so yes, this is the main file. I think yes. Now let us change something. Instead of hello.txt, let us write different file. Okay, so we can get the exact idea what is happening over here, right? So I will not change this message. Okay, I will simply change my content if required. So instead of this one, let us write 1111 and 2222. Okay, and our file name. So this is the file name hello.txt. So I will write hello hardware coding. This will be the file name next time. Now just releasing the target, uploading it back. Let us check this. And after successfully updating, here is the message. 1 minute, something is happening. What happened? Mounting, initialize mount successfully. Open file, error, write fail, SD unmount. Okay, let me reset this. Okay, okay, I know the error. Actually, the name is little bit longer. I think this is also not supported. We have to follow some basic simple rule. Code.txt, right? So this is just a issue of file name only, right? Some predefined formats are that we have to follow that. Too much complex name is not allowed for now. We have to set something, and this is what, right? So here you can see we are able to write successfully code.txt. Okay, and here it is also showing you that previous file was hello and second is code. In code we have some message. Right now let me just remove the SD card from this. So let me just remove this SD card. Okay, now I have to just insert this SD card into this module, and I have to just connect it here. And you can see we have two files. One is a hello, second is a code. Let us open hello. Here you can see append file 1111, and here is the hello file. So using this driver, you can simply write the code, right? And the reason behind long name is not supporting, I will add this in the description. Okay, and next time in data logger part, I will also demonstrate you how we can use the longer name. But for now, I'm just using the simple name, and that is how it is working again. So this is what for the today's video. If you like the work, then please subscribe the channel, like the video, share it with the friend. And now we have started this series again. So I will upload video weekly for this series. So till then, bye bye. Thanks a lot for watching this.